All right, well, my clock is showing 1 o'clock, so let's go ahead and get started, and folks can continue to find their way in. Well, welcome everybody. Happy almost October here. Hard to believe September is come and gone. Um, but want to thank you all for joining us today. We're going to be talking about steam trap testing and all the great work they're doing with that at DuPont. We've got Guidry joining us, who has a lot he can share with us about what they're doing at DuPont. So obviously a great presenter for us. Oh, got a little ahead of myself. Just a little bit about UE Systems. So for over 40 years now, we've been producing ultrasound equipment that folks throughout the globe are using for monitoring their rotating equipment, bearings, leak detection, electrical inspections, and of course also steam trap testing. So what better time to start talking about our steam systems and the different inspections that we can be doing and how ultrasound fits in than right now at this time of year as things are going to start to cool off and we're going to start needing to get those systems up and running. So we met a couple years back, well obviously as a customer, but a couple years ago met him at our Ultrasound World Conference where he presented on all the great work that they're doing at DuPont. And he had such a great story to share about all the traveling he does throughout the country doing not only compressed air leak detection inspections, but also inspecting all the different steam systems that they've got at all their different plants. So we heard from him a couple years back and thought it'd be great to bring him back and see how things are going, see what's changed, and let him share with maybe a new audience now. How things are going and what he can maybe provide to you all as some best practices. So we're looking forward to V presenting with us today. Just some housekeeping. I am recording this, so if you have to hop off early or if you've got coworkers that you really think need to see this, we'll have the recording of this up on our website, hopefully by the end of today or tomorrow. And so that's one thing to make you aware of. And also, if you've got questions throughout, you can type those in. I'll be monitoring those, and I'll get those asked to V as it makes sense. And then, of course, at the end, we'll have some Q&A time. And even though you can't see V, I'll give you a little hint. He's probably wearing an LSU shirt, so you can maybe picture him in a purple shirt with what is it, a tiger or a lion? A tiger, right? So just a little bit about V there. But I'm going to change the screen over to him and let him take it away. And with that, V, I'll let you get started.
All right. Good afternoon, everyone. As Maureen said, I'm V. Guidry. I work with DuPont out of the Energy Engineering Group. I've been with the company going to be 34 years in a couple days, and I've been doing steam traps for probably 30 of those years, and been working with compressed air systems for about the past 10, all using ultrasonic leak detection equipment. What we'll discuss today is some of the experiences that we had at our plant sites throughout DuPont since 2007. We're basically when we started actually monitoring and maintaining our systems using ultrasonic leak detection. So this is a little bit about me. I didn't have my purple shirt on for the picture here, but I am an LSU Tiger fan, so don't hold that against me. But as you can see, areas of expertise, I've been doing, like I said, steam traps and all, but I am level 1 certified through UE Systems, and I've been using their equipment, which is a great piece of equipment and very versatile tool. So, in my travels throughout the U.S. and even outside of the country, I get more and more requests for plant sites to use or purchase the ultrasonic equipment. After they see the surveys that I do and the reports that I put out, they realize how important ultrasonic leak detection is. So if anybody needs to get in touch with me, I have my phone numbers here and all, and any questions, as Maureen said, that we can try to answer either this afternoon or later on through by emails or whatever. A little bit about our business. DuPont has kind of downsized over the past couple years. We split with, I guess as everybody knows, with Chemours and all, but we still have a quite a few sites left, and these are the primary businesses, and the plants associated with these diverse businesses are located worldwide. Like I said, I've been to several of them outside the country. Haven't been to Asia Pacific or whatever, but you know, my schedule's pretty full as it is, so try to limit my travels. Surveys have been done by plant sites based primarily in the U.S., Canada, and the Caribbean, and I've performed some surveys at some of our European sites and also some of our customers that we try to give them a hand on trying to identify and reduce costs for them. A little bit about the technology. You know, we use ultrasonic leak detection to identify and correct defects that can negatively impact energy use and cost in several systems. You know, as Maureen mentioned before, in compressed gas systems, they can be used in hydraulic systems. Mechanical equipment, steam traps is basically what we're going to talk about today, the steam systems, and even vacuum leaks. The technology is quite versatile, and we've been using this to assessing and troubleshooting a variety of mechanical issues in site systems and equipment. And we feel that the technology is an integral part of a facility's reliability and mechanical technology toolbox. And the proper use of this the technology requires appropriate level of training. And that's some of the main things that we try to stress is when I go to the plant sites is training is the most important tool that we can provide to our plant sites and our customers. If we just give people very expensive equipment and tell them to go use it, you know, as they say, bad data in, bad data out, that's exactly what we're going to get. We're not going to get the correct and appropriate feedback that we need from our surveys. So in doing this, you know, the question we always ask is, who's looking at these systems on your plant sites? In general, the primary purpose is to help our plants identify and correct defects. However, the perspective is more of a broader picture. Items relating to other aspects of energy associated with these systems can be directly impacting manufacturing reliability, safety and sustainability, and mechanical integrity. Finally, you know, we attempt to put into place the sense of awareness, the knowledge, and the tools necessary for sites to achieve the benefits and to sustain the best practices. So, you know, a lot of people ask what I do. Well, this is what I do. The steam trap survey process can be very hectic at times. What we try to do is we try to set up a steam trap database that's established and entered into Excel spreadsheet. There are some computer-based programs out in general that can be used. There's a lot of good information you can get and store in computer-based programs, but right now we're still in the process, since we're going to so many different sites and with costs associated with that, we've decided to stick with our spreadsheets. Now, the spreadsheets that we use can calculate everything that most of these computerized programs do, but it's kind of a little bit different on the reporting side of it. But typically, DuPont uses 2 or 3 test methods, for testing steam traps. There's sight, sound, and temperature. The 2 we basically use is sound with ultrasonic leak detection, and temperature, which I use a little handheld infrared camera. You know, there's spot, you know, contact parameters and spot infrared thermometers and all. But one thing when using infrared, you got to watch with the reflectivity off of shiny objects. You might not get true readings on temperatures. But all the traps on site are surveyed. Again, I use intrinsically safe. Right now I have the UP9000 ATEX and the intrinsically safe FLIR infrared I5 camera. Once the defects are identified, I hang a red trap leak tag on the trap, and that's used to identify that there is a defective piece of equipment there. And it also lets the people in the area know that there's an issue with this piece of equipment. A lot of people just kind of walk through the areas day in and day out, not noticing too much difference of, you know, things happening in the field. But when they see these red trap tags, they start asking questions, which is good, because then they know that we have issues with some of their traps. And all the traps that are identified as failed are written up within the spreadsheet. We use that for work order generation and cost avoidance calculations. And the spreadsheet data is sent to the areas that where the repairs can be made, because I have it broken up that where we could break out different areas on the plant site, so it wouldn't be one giant spreadsheet that we send into people that might not be interested if it's not their area. And then what we do is we have what we call site energy champions within DuPont. That's kind of the overall lead with any energy associated projects. Some other companies might be just basically area reliability engineers or energy leaders or whatever you may have at your plant sites. But what we do is we try to get this spreadsheet to them to where they're like the keeper of the spreadsheet, so they'll take care of any updates and that can be made in there. And they also make sure that they follow up on work order generation for all the failed traps that we find. Once the repairs are made, we ask that the red leak tags are pulled from the field and returned back to either the site energy champion, or reliability engineer, or even the area planner that may be following up on closing out work orders. That way we know the job is actually completed. And then the reports are generated and then sent to management. Some of the equipment that we use, like I said earlier, I use the 9000 ATEX, and this is basically the kit that it comes with. Of course, I bought a bunch of fancy gadgets that go with mine for use within compressed air and steam traps, extension poles, flexible probes, and all. I mean, there's a wide variety of accessories that can be used with the equipment. And as you get more experience in testing traps, or even with doing compressed air leaks, you see and find needs of different modifications you may have to make, or actually, you know, make different things to assist you with doing your surveys. But as you can see here, there are, you know, several detections, different leak detectors. But in this photo in the upper left-hand corner, you can see that he's using a UP9000, but the headphone is not attached. If you could see, I don't know if you can see my cursor passing over, this little jack plug right here is where the headphones should be inserted. I don't recommend testing steam traps without using the headphones. In this case, he's testing thermodynamic dish traps, would have a distinctive on-off cycle. They can be very loud, and if you have your sensitivity adjusted a little bit too high with the headphones on and it discharges, it could be kind of uncomfortable to your ears. You can still see the bar graph increase and decrease during cycles, but without the headphones, you can't listen to see if there's a leak in between cycles. And a lot of times on dish traps, once the disc in the seat starts to get worn out, you'll actually pick up that slight leakage in between cycles, and that's when we start losing live steam. But on the bottom, you can see different scanning modules and tone generators that can be used for different type of testing techniques. Steam systems within DuPont, I'm sure steam systems are not, you know, just for DuPont. I mean, every plant site has them, every industry and business has them, no matter if you're a hospital, if you're a, you know, oil manufacturing facility, chemicals, pharmaceuticals, just about everybody has steam. Everybody's going to have a steam generation facility. There can be thousands of running feet of pipe within the steam distribution system, and hundreds to even thousands of steam traps on site. There's also a diverse mix of steam traps and trap applications, different pressures, different applications in the utilities and process areas. In addition to the inefficiency and steam loss, other energy-related items associated with surveying these systems can include improving steam trap and steam condensate leak management via best practices. DuPont has an entire library of best practices that we use for any type of inspection, any type of program that we can use or have. We're also assessing steam traps and associated steam and condensate piping. That's steam traps. We want to make sure they're functioning. They can be failed open, failed closed, or any subset of the others observed conditions. We want to confirm the steam trap application, type, and installations. Visually examine the steam supply and condensate piping, the connections, the fittings, the insulation, and the ease and access of testing and maintenance. Many years ago, we observed what we call the iceberg effect that's associated with steam traps and steam trap management. So one thing we have to remember that steam traps is only a small part of the steam system. But when we're having problems with steam systems, the steam traps are the first thing to get blamed that something is wrong with it. In addition to energy-related items associated with these surveying systems, we also identify opportunities to reuse condensate in the area, like for splash tanks, heat exchangers, etc. Condensate is already hot, it's already treated, so you want to try to get that back to your boilers. That way you use less makeup water and less heat on it. So you save a lot of money by returning your condensate. You also are looking to identify misapplication or poor utilization of the steam. We also surveys provide an opportunity to identify or assess potential safety design, system design, and mechanical integrity issues. Safety, hydraulic shock, or water hammer. I mean, I'm sure if you've been around the steam system long enough, no matter if you've been at the plant for 40 years or if you're the first month you're on the plant site, you hear some pinging and banging, water hammer in the steam headers. One thing you have to remember is water hammer is not normal. Steam systems should not be banging and hammering. So, you know, it could be because the system can't remove the condensate. It could be some traps that are failed closed. It could be an isolated valve that you can't see anywhere that might be leaking through or cracked open. There's a lot of different things that can cause water hammer. You can have leaks or venting that leads to incremental increases in your emissions, water use, and chemical treatment, and material condition of the installation, the amount of bare piping or components, and the proximity of equipment to and from personnel. You know, a lot of times we have, you know, mostly insulation on all our steam pipings. Over the years, it starts to degrade, so your efficiency and your effectiveness of the insulation starts to deteriorate. So you could start by causing more condensing of the steam, you know, starting to have more water in the systems that could start having effects on water hammer. When we start getting more water condensate in the systems, the temperature starts dropping, the pressure starts dropping. So there's a lot of issues that if we don't remove that condensate, you know, we can have some serious equipment issues. As far as mechanical integrity issues, system discharge points, flash steam in the proximity to personnel or vehicular traffic. You can have issues with thermal burns, either direct or indirect contact, steam plume or vapor clouds from flash stream and vented condensers, condensing vapor, pooled condensate, and potential for freezing. Of course, down south here in Louisiana, we don't have that issue that much, but you know, up north, being that now it's starting to get into the cooler season here, we want to make sure that our systems are properly trapped and removing that condensate, because you know, we can freeze up not only just little tracing lines, but big steam headers as well. There's a lot of noise associated with trap discharge and the erosion of the trap drain area associated with condensate discharge over time. Some mechanical integrity issues, you're going to have pipe and fitting corrosion, erosion from adjacent leaks or direct contact with other piping, and associated the location and condition of expansion joints, pipe hangers, and supports. Some design issues that can be adequate system or component isolation valves, sufficient system high point vents and low point drains, and adequate provisions for support and thermal expansions. The spreadsheets that I use while I'm doing these surveys actually has columns and cells with drop downs in them that we can identify certain issues that we find being safety, mechanical integrity, or design, even insulation issues, that we can, instead of having to type a whole bunch of stuff, we can go through the drop-down list, click on one item, and it automatically fills in for us. So we're not only just testing the trap if it's good or bad, we're also doing many insulation surveys, design surveys, making sure that we have the right traps for the right applications. During the surveys also we do steam loss, steam leaks, and the leaks would add artificial demand to the system, or losses an opportunity of effective utilizing or returning condensate, basically what we use in pounds per hour. Leaks can lead to incremental increases in emissions, water use, and chemical treatment. Pipe and or fitting material conditions. Material conditions of insulation and the proximity to personnel. A lot of our plant sites are very old, and a lot of these old sites still contain some asbestos. So you have to watch when you're going around bumping insulation or removing valves or traps, making sure you don't disturb the insulation too much. We look at the vents of flash steam in the proximity of personnel or vehicular traffic, again, which can cause thermal burns. Vapor clouds, once they get dense enough in the wintertime, you can't even see through them, so you don't know where you would be walking. You could end up with a tripping hazard or something on that nature. And the noise of the vented steam, which in some cases it could sound like the space shuttle taking off. Mechanical integrity, the condition of the piping, the fittings, the valves, the packing, etc. Again, we can document these things on a spreadsheet, which you're not only writing up a steam trap that's defective and getting a work order on that, we're also writing up if there's a valve needs to be replaced, or a valve packing leak that we can try to tighten up, or piping and fittings that need to be replaced as well. And the reliability aspect of it is, do existing mechanical isolation valves function properly? We'll see that we have isolation valves, but they look so old that you'd be scared to turn them because you might break the valve stem off on them. So we have to watch at that part. But in effect, there's a lot more to managing steam traps, and far greater value can be derived if you maintain a systems approach to steam trap and steam leak surveys. And though DuPont makes use of the process of heat recovery, most of the steam is generated in conventionally fired boilers. And one thing we have to remember, and we have to get that word out to all the people in the areas, is steam is not free. I hear that all the time, that we're not worried about that because steam is free, water's free, air is free. That's a misconception that we have. Not, a lot of people are not familiar with the steam system or utilities in general. So that's one thing that we try to set the point during our training sessions, and actually during our surveys, is that whatever we see here leaking or not working properly is costing us a lot of money. So in general, who's looking at your steam systems and components on this level, or this, being this thorough in it? Going into some of the data that we've covered, and this slide here basically just shows from what was done in 2004 till present, 2014, I'm sorry, till present day. I've conducted 18 steam trap and steam leak surveys, identified steam loss and steam traps of about 141 million pounds per year, or 16,000 pounds per hour. The cost of the steam trap leaks was almost $1 million per year. The percent of steam trap failures, which when we figure in failure rates, DuPont calculates the failure rate using only the traps that are in service at the time of testing against the number of failed traps, that are actually failed during that survey. I've seen it to where some entities use the entire trap population versus what's failed, so it can give you a false pretense of what you actually have going on out in your areas and in the units as well. What we like to do is make sure that we get a failure rate of the traps that are actually in service. So anything that's out of service, disconnected, that's documented as missing, that's taken out of the equation. So from if you look at it from that rate of 4.24% average of all traps tested, and that ranged anywhere from a little under 3% to 39%. So if we did it with all the traps in service, you're looking at a 6.43% failure rate. So you can see, even though in just 18 surveys, that's a 2% difference in failure rates. But if you want to make sure you stay consistent with what you're doing. You don't want to one time use all your traps and in the next survey just use with traps in service. So the main thing is being consistent on whatever formula you use to calculate your failure rates. As far as identified steam loss from steam leaks, I mean, we look in here at almost 42 million pounds per year, 4,800 pounds per hour, costing us a little over $300,000 per year. And then again, with your costs associated with steam leaks, we calculate on our steam cost per 1,000 pounds, and it's different at every plant site. It's different for every region, depending on what time of the year it is. If natural gas prices go through the roof, if oil prices drop, vice versa, you know, these costs fluctuate. So we try to take a 6 months average of our cost associated with steam to try to calculate our cost avoidances of what we use for wasting. The safety, health, environmental impact, emissions of CO2 gases within this past year was about 6.2 million pounds per year, about 3.1 tons. The water loss, which is basically our makeup water that we have to remake boiler feed water, 738 gallons per hour, or 6.3 million gallons per year. So total loss identified from steam trap and steam leak surveys was equivalent to about a 400 horsepower fire tube boiler. Now, next slide here is basically survey data since 2007, and I've conducted 94 steam trap and steam leak surveys, identified a total loss of over 2 billion pounds or 230,000 pounds per hour in steam loss. Again, that's with failed open or leaking steam traps and steam leaks. The cost of the steam trap leaks alone is almost $13 million. The average percent failure rate since 2007 is about 11.36%. We mentioned earlier about best practices. DuPont, you know, we have different levels of what we try to get is like best of the best, world class as far as steam trap failure rates. Best of the best, we try to get at 5% or under. World class in general for all industry would be less than 2%. The only way to maintain that type or that level of failure rate or steam trap management, having a proper program in place with people identified and working on this. You know, it's not just a temporary part-time job that you do a survey and you're done with it for a year. You have to maintain the equipment. You have to maintain your piping systems. Once you let that go, that failure rate will climb up really high, and these numbers I'm showing here can, you know, in a matter of a couple of years can almost double. So again, with the steam leaks, you know, the loss of steam, 488 million pounds per year, 55,000 pounds per hour, $3.4 million that we've just wasted. When you talk about just, you know, blowing it to the wind, that's exactly what we're doing when we have steam leaks in the areas. The impact on emissions, we got 63 million pounds per year, or 31,000 tons per year. And water makeup is, you know, 56.8 million gallons per year. That's a whole river that you waste and just letting steam go by. Some of the charts that I put together, again, these are going to be since we started the programs and monitoring closely in 2007. You can see our failure rate chart. In 2007, it was an average of 14% failure rate. Some sites were as high as 35–40%. We didn't get below 10% on not many of them. As we started getting in and started putting the programs in place, you could see, like after 2009, when more and more sites started getting on board with the best practices and realizing that there's a lot of low-hanging fruit, as we call it, as far as steam trap maintenance and repair to capture some of these wastes. You could see how the trend gradually went down over the years. And, you know, right now it's, you know, on average about 2015, it's a little under 6%, but, you know, we've only done a few surveys so far this year. So, you know, hopefully it doesn't get that much higher when I finish my next 6 surveys before the end of the year. Steam loss, pounds per year. In general, you see that when your failure rate drops, you usually see your steam usage and your waste drop as well. But in this chart, you can see that in 2015, our steam loss has increased. But this is due to several of the sites that I surveyed so far this year. They had a lot of high-pressure steam systems there, high pressure, high dollar amount, high leak rate. So you're going to have a tendency to see an increase in your steam loss. Even though your failure rate's going down, the few traps that we are finding failed were on the higher pressure systems, which caused us to have a little larger than normal steam loss leak. And then you can see the same here is with the trend of the dollar amount loss follows the failure rate pretty closely. You'll see that they're going to have spikes in the trends with steam trap failures. Most commonly, we see this during startup and shutdowns of our plants. You know, having processes. We need to have process in place to blow down our steam headers and steam systems. Because if we just starting up and shutting down without trying to remove the trash from the steam systems, we basically could just send that trash straight to the steam traps, and it's going to cause a premature failure. So if we can put some processes in place, you know you're going down on a steam system, you know, get a group of guys together to have access to blow down the main headers to get all the sludge and trash out, and protect the traps, isolate them before you try to let all that trash go through. And same thing on startup, you want to purge your systems before you introduce that steam into the main process applications and to your main steam traps. Overall observations and defects. You know, steam traps is a mechanical device. They will and do fail. Two basic different types of failure modes are failed open and failed close. On failed open, we use 3 different leak levels on thermodynamic dish traps, which is either failed open, rapid cycling, or leaking. And within the spreadsheet, we actually have a breakdown percentage-wise of if I got a trap that's leaking, it might be only wasting 30% compared to a trap that's blowing through at 80 or 90% of blow-through capability. So we do have get a little conservative on our leak rates when it comes to that part. But when traps are leaking through, they're not operating properly, they're not going to be efficient. What's going to happen is it's going to increase your steam use and or loss of live steam. It'll increase in your BTU per pound, which is a key performance indicator that DuPont uses in tracking in steam systems. And we can overpressure condensate return systems, the trap that's blowing through into a closed loop system. You're going to get water hammer and improper heat transfer, or the inability to maintain your heat and your throughput. If a trap is failed close, well, hey, we're not losing any live steam, so we're not wasting money that way. But what we end up doing is we're backing up condensate into the steam headers and into our heat exchangers. And what's happening there is you start getting poor steam quality, get poor heat transfer. You're going to have a possibility of water hammer. Once you start flooding heat exchangers, you get the formation of carbonic acid, which is the corrosion and loss of a mechanical integrity of the equipment. So, you know, even though we're not losing money outright with a failed close trap, we shouldn't just leave that trap failed and isolated and backing up condensate. Work order should be written on it. Same thing as a failed open steam trap. You just don't want to let it continue to blow through, and you don't want to valve it out to say, hey, I'll stop the steam leak. Well, then we get into failed close conditions where we're backing up condensate and we're eating up our equipment on the inside. Trap failures represent about 65% of the total steam or energy loss, roughly about 62% of our energy costs. Steam leaks, those failures represent about 35% of energy loss, roughly 38% of the energy cost. The leaks from the piping systems and fittings and joints, you're going to have valve packing leaks. We've got strainer blowdown valves that leak through. A lot of people like to bleed off on the strainers before the trap to make sure the system stays hot, but what we have to remember is if we're blowing down steam before a steam trap, we're actually losing our efficiency inside the equipment we're trying to maintain heat on. We lose a lot of latent heat. The pressure drops, the temperature drops. So even though we see live steam coming out, it'll be kind of hard to maintain our system pressures in set points if we're blowing down before the trap. We'll see leaks at piping, tubing, fittings, and connections. A lot of times a tubing will get crushed, or just fittings are loose and they start wearing out, blowing through. It could be internal corrosion. It could be external erosion. Friction, rubbing on pipes or tubing can cause leaks. And steam hose is used for surface heating instead of jacketed or tracing systems. There's a lot of waste when you open up a 3/4 inch steam hose, just blowing it on a transmitter to try to keep it hot and keep it from freezing during the wintertime. A lot of times that water on the transmitter will cause more headaches than with actually trying to keep it warm. Some more observations. Most steam trap and steam leak survey defects can be easily identified and corrected by routine ultrasonic leak detection surveys. Again, and I can't stress this enough to my folks that I do the training on, the surveyors must be trained. I mean, and the steam trap personnel must be trained. We can do the best, surveys in the world, the best reporting in the world, but if we try to just pawn it off on someone that, hey, we need a survey done, go ahead and do it for me, and they're not properly trained on it, again, we're just not going to get the results that we need. We're going to miss a lot out in the fields. Even with the maintenance personnel, if they're not properly trained on how to install steam traps, they may take a trap out that's failed, but it's installed wrong. They're going to put it right back in the same way, and the trap's going to fail again. Because if you're not familiar with each type trap and trap technology, all traps are position sensitive when you install them, because they have to be in a certain position for them to operate correctly. So if we're not training our area personnel either how to test the traps or how to install them correctly, we're shooting ourselves in the foot by our lack of training on that part. Applying ultrasonic leak detection in areas where system components are difficult to access is extremely valuable, and defects involving misapplication or misuse of steam exist due to the lack of awareness and or our complacency. Going into a little bit of the training advertisement that we do, again, the training that I offer basically comes from UE Systems, where they trained me several years back. I got certified through their process and their program, and I take bits and pieces of their training that we have and put it directly into our field and hands-on training as well as classroom training. And we started this back in 2010, and we have it split like with 2-day sessions. Day one is ultrasonic leak detection, how to use the equipment, how to do airborne leak surveys. We go out in the field after lunch. We do mini surveys. We come back in the classroom or meeting room, and we discuss what we did. We share our findings. I'll show them how to use the spreadsheet to enter that data and show the calculations of the savings and potential cost avoidances of what we found just in that just in a couple hours. The money that you can save in leaks that are found or defective traps that are found actually pays for that person's time, basically almost the entire year. So the payback on these type programs are unbelievable. So, I mean, that's why I stress strongly that, this should be a full-time job at every plant site, to where, depending on how many traps you have, it could be 1, 2, or 3 people full-time doing steam traps and compressed gas leak surveys, and the plant will reap all the benefits that they could ever think of. And like the day 2 section of it, the same thing is, it's all about steam traps, steam trap operation. We go through the steam cycle, steam distribution. We do testing techniques. We show the different type traps. Have some little videos of how the traps operate. We have cutaways. We have glass line traps in the videos that show the participants how they operate, what to listen for. And, the main thing is the operators, the mechanics, most of the site personnel know the process side of their plant site like the back of their hand. When you ask them about the steam system, steam distribution, steam operation in the processes. A lot of times it's sad that, you know, they don't have much of a clue on all they know is, well, we got to have steam to keep it hot, but they're not familiar, you know, and no one's there to train them on the steam systems. And that's something that I try to do when I go to a plant site, is take the area engineers, the operators, and mechanics, and we do a walkthrough on the steam system. And I try to explain as much as possible of, you know, what can be expected, what we're looking for, why steam, you know, why we need steam, why we need to have steam traps. And it kind of gives them enough information to where, you know, it's like, okay, we need to look into this a lot more. And, you know, from the sites that's we help to develop steam trap programs, it also helped them to look at the entire steam system, from the boilers through distribution, through process, back to the boilers again. So it's a win-win once we get that route going in. Just some of the training sessions that we've had with airborne emissions and steam traps. I've conducted right at 29 sessions. Airborne, we had 215 participants from 33 sites. Steam traps, we had 200 participants. And that, you know, it could be, we have operators, we have mechanics, area engineers, we got supervisors, we have reliability technicians. We've got, you know, I've had some plant managers sit in. We've got, you know, unit managers, black belts. You know, I like to have everybody attend the training sessions just to get them to get that bug in the ear saying that, hey, we really need to do something on our steam system. So we've also done some extended field training, techniques, and troubleshooting. Not only, you know, if a site has issues that, you know, steam problems, can't figure it out or whatever, I'll get a call to come in. We get out a little bit, get the people out in the field. They explain to me the issues that they're having. You know, we go to look at it. We try to figure out, you know, write a list of everything we find wrong or the what-if chain that we go through. And, you know, it helps me understand their process, but I can help them understand the steam side of it. And that's something that, you know, DuPont has a lot of experience and expertise in the different fields of throughout all our process and our applications. So we have, you know, a wide array of folks that we can go to for different type of issues or experiences that's needed. So some of the final thoughts, you know, with expanded presence worldwide, DuPont sites, you know, which we said must include routine use of ultrasonics in their site-based maintenance and technology toolbox. We don't tell them that ultrasonics is going to replace all of their non-destructive testing, all of their vibration monitoring or infrared surveys. We just ask that they incorporate ultrasonics along with those programs for a better aid to help them to better troubleshoot and pinpoint issues. A lot of the smaller sites, you know, we do networking and training. Some of the sites we have are so small that they can't afford to buy certain pieces of test equipment and all. So what we do is we try to leverage tools and personnel to these sites. That way it could be like used at the site regionally or global networking. I have broken up a networking program here within DuPont to where we have it broke up in each region, you know, Gulf Coast, Mid-America, Southeast, Northeast region. I have a distribution list, email list that I have over 300 names on it, but combined with all the different regions. So if I have something I want to put out to the network, I just write one email and it, you know, it flies through to everybody. They have questions, whatever, they email me back. And that's how I get a lot of work is sites starting to have problems with different things. And you know, we can put memos out and they can request services and we can go through and provide the training and the surveys that's needed on that part. We also offer webinars, face-to-face training, and we also have some computer-based aids. So I'm starting to get hoarse. I'm finished here. So if Maureen wants to take back over and try to answer any questions, if we have any time, we're good. So thank you all, and if there's anything that we can help you with or questions we could answer, we can go for it.
All right. Well, thanks, V. That was great, and hopefully you've got a little bit left in you to get some of these questions answered. But you kept mentioning the importance of the training and even some of the payback that sites will receive from having the proper training in place. But have you found that it's been hard to get that training approved? Do you have to like really push the business case, or do you have enough data that it's like a no-brainer for the the decision makers to say, yeah, okay, these guys can go to this training?
Well, I wish it was a no-brainer. But yeah, we do have issues. I mean, a lot of it is travel. I mean, we'd like to get a group of people to go and sit in at the manufacturer's training sessions, or we give them options that we could bring in the manufacturer to do training for us, or I go to do the training session just to give them a little more incentive to say, hey, we learned this much through V. Let's send them to get the real professional training at the manufacturer, that how much more we can grasp with that. But that's part of what we try to do is we try to get with management and tell them that this training that they're going to receive is going to more than pay for itself in a couple weeks.
Yeah. Okay. That just seems to be always the sticky widget, getting that approval, even though you've got the business case. So anyway, all right. So a couple questions here. One, what is the best way to test traps with high back condensate pressure?
It depends what the inlet pressure is. A lot of times, if you have a high condensate return line pressure, the trap is not going to operate efficiently as normal, so it'll have a tendency to back up condensate. If it's on a process heat exchange, it could go into stall to where the condensate's not going to move at all. So a lot of times what we do is if you have the capability of valving out the condensate header side of the trap and have a drain valve on the discharge of the trap, to open that valve and actually watch the trap operate to make sure the trap is operating properly, then you know that with the back pressure on the trap, it's going to decrease your condensate load through the trap. So there's a couple of tricks that you can do for that, but like I said, depending on how much differential pressure you have on the trap itself, it'll be how the trap is going to actually function.
All right. Then I've got actually several people kind of asking similar things around, and you touched on it a little bit, but around using infrared either in conjunction with ultrasound or separate from. Do you have, what's your best recommendation? Are you using ultrasound or infrared? And maybe just talk a little bit about how you feel the two complement each other, or use
definitely use both.
Yeah.
The infrared gives me an indication of the pressure of the steam that I'm testing. So, that's all important when it's time to calculate and loss and all. But like I said earlier in my presentation, I use ultrasonics and infrared. I can take, especially infrared is great if you have a trap 10, 15, 20 foot overhead. I can do a scan of a trap and I could actually see where the steam and condensate separate in the trap. So if the trap is blowing through, you'll be hot all the way across the trap. If it's operating properly, I'll have heat on the inlet and cool on the exit. So I don't recommend just using infrared alone, but in some cases that's all we have to do because of the location of the trap. But I mean, by using both of them, you end up with a 95% accuracy rating on actually identifying the trap is good or bad.
Okay. And maybe just touch on again the frequency of the inspections that you all perform.
Most of the sites right now that I go through is like on an annual survey. Again, depending on how many traps you have on site. Some sites that's got a lot of, very important critical type steam traps, we try to do that quarterly. But I prefer to do a biannual surveys. That way we catch the heating season coming in the wintertime, and then we do it in the summertime and catch, coming out of it. So, twice a year to me would be ideal.
Okay. And then this might be a little broad, but maybe you can just kind of give a few top tips to this person. But they're wondering if they were to initiate a STEAM system survey, what would be the best approach to kind of get started? So maybe you can give your little hit list of
drawings. Pull every drawing you could find on your STEAM systems, because you have to make sure your drawings are up to date, and that's one thing about doing a STEAM system audit is updating drawings as you go along. Start at the boilers, you know, follow your piping through, make sure that you have the proper expansion loops in your steam system, make sure you have the proper amount of drip traps and drip leg stations, proper traps per application, you know, insulation, make sure everything's insulated properly. Let's see. And then, you know, going through testing, you know, once you start testing, you have to make sure that, you know, you have a right trap on a process application versus a drip application. And by going through these type systems, you know, it'll take you several times going through the initial plant survey to get all information documented and correct, because you'll walk through and you'll find a bunch of traps, you'll mark them down, and then when you go through your second time, you find ones that you missed, and that's normal. I mean, you can't, you know, it's going to take you forever if you know, tracing each piping and not knowing really what you're looking for. So again, that's where the training part comes in, steam system training and steam trap training, to be able to identify a steam trap by what the trap looks like in conjunction with what technology trap it is.
All right. And then this one kind of ties to the two questions back about how often you do the inspections, but how long does each inspection excuse me, now I'm at a loss for words here. How long do the inspections tend to last for each individual trap?
Oh, testing a trap?
Yeah, like about how long does it take?
Well, what I do in my training is like when I test a trap, I could probably test it in about 5 seconds. Knowing that I have the proper temperature reading is why we use infrared, making sure the trap is hot and operating properly. And then while I'm doing infrared, I'm listening to the trap. When I'm training people for the first time, I'll make sure they listen to the trap cycle several times. So when you're first starting out, it may be a minute or so, just listening to the trap to try to get the characteristics of the trap discharge. And then as you progress and get more experience with it, you can cut that down to 15, 20 seconds per trap, and then, you know, you can start moving from there. But in general, if you're kind of just starting out, probably about a minute per trap.
Okay. All right, great. Well, there's some other questions that some folks have asked that I think will be best handled, you know, maybe offline or with some help from our UE team. So we'll be, if you've asked a question and we didn't get to it, we will definitely get back to you via email or a phone call to get those answered. Just to cover a couple other questions, we did, or I am recording this, so we will have the recording available on our website. And you did have your contact info up there at the beginning, right? So maybe a couple of these people that are asking, is it all right if I share your contact info with them that want to get in touch with you after the fact? Is that okay?
Yep, it was up there in the beginning, so
yeah,
it's
okay.
out there.
Perfect. All right. Okay, well, I am just going to take the screen back from you and do a couple closing slides. Again, like I said, if you've got questions we didn't get to, I promise we'll reach out to you all individually to get those things answered. But in the interest of time, just to wrap up, so lots and lots of information on our website, uesystems.com, lots of information around the topic from today, and then of course the other applications. Some of the questions that were coming in were about what other applications that you can use ultrasound for. So definitely check out our website. We've got, you know, the recordings of all of our webinars, presentations from the past conferences. So just a wealth of information. And if there's something you can't find, just let us know and we'll hunt it down for you or point you in the right direction. So hopefully you can find that to be a pretty powerful resource. You know, definitely it always reminds me when we have webinars like this with the questions that come in, and it does seem to stir up a lot of discussion. So welcome you all to take a look at our different LinkedIn groups we've got. We have our UltraProbe users group and our Reliable Asset World group on LinkedIn. Great place to take some of the questions that you guys have today, just to get feedback from your peers like V. It's just a great community. Lots of folks checking in there daily, providing feedback, helping to answer questions or asking questions. Just a good place to take the conversation from today and get some different perspectives. So definitely check those things out. And then just a couple save the dates for you. Our next webinar is going to be on October 20th. We've got Chuck Jarrell from Campbell Soup, who's going to be kind of talking about the people side of predictive maintenance and reliability programs and how you can really, get folks on board and do a lot of the things that V was talking about today. He's a great presenter, should be a really good webinar. And then November 4th, we've got Joe Anderson with the Smuckers, talking about selling maintenance as a profit center. So another kind of business case management type webinar, but both excellent presenters, and we'll have invites out for those to you guys. And then never too early to save the dates for our conferences, Ultrasound World and Reliable Asset World next May 10 through the 13th in Clearwater Beach, Florida. Great presentations, just like what you heard V do today. That's exactly the kind of information that we share at the conferences. So if you can get those dates on your calendar, we'd love to see you there. And with that, we'll put our contact info up. I'll thank you again, V, for taking the time out of your day. I know you said you're going to be on the road now starting tomorrow for the next month. So safe travels. Hope you get a lot of good data, and we'll look forward to having you back sometime to share it with us. So
thank you very much.
Everybody have a great rest of the day, and we'll see you all hopefully next month on our next webinar. So enjoy.